to the 15,000 people who are still out for different reasons. So if you open it up to the third page, I did autofocus and it did not stay, and that makes me mad because this thing is supposed to work. Alright, that's a little better. Little, moderately, as in still want to beat it with a stick kind of stuff. Okay, so on page 3 is all your inferential statistics stuff. Inference is your decision making, hypothesis testing, and confidence interval. And so we've not really looked at it at all. So it's time to take a look. So the very first thing you see is the standardized test statistic, which is a fancy word for z-score. And it's the fancy word for z-score because in later chapters we'll learn how to do a t-score, and it's exactly the same formula. So they make it generic for that reason. So the test statistic is the statistic we're trying to figure out where it is on a normal curve when we run our test. It's the statistic, that's p hat, minus the parameter, that's the mu, that's the mean of the distribution, and over standard deviation. And the standard deviation formula is down here under single samples, sample proportions, that's that square root of p times q over n. So you plug that into there to get your z-score. So, of course, at this point in time, if you haven't learned how to do a z-score without looking up a formula, we kind of in big trouble already, okay? But if we haven't gotten it yet, you still have time to recover that information, but the pieces that plug in up here are all down there. So the second thing you see is the confidence interval. Now, this is a different version than yours. I've got an older book, you've got a different book. Yours says estimate here instead of statistic, doesn't it? Okay, I messed that up. I should have run this copy off, and I didn't catch it till it was too late, like, today. And you already become one with your blue book, so it's too late to reprint those. So a statistic is just your estimate from a sample. So that's the same thing. For us, that's a p hat, and I wrote it on the board over there just because sometimes it just helps have that visual. So for us, that statistic or estimate was the p hat from a sample. Plus or minus the critical value, which is the z star. That'll become a t-star in later chapters. Same idea. Times the standard deviation of the statistic, which is the standard error, that square root of pq over n, which is hats in a confidence interval. And the formula for that, again, is down here in this box, and you can just plug it in. All right? So this is the generic version of the confidence interval that's over there on the board. So today we graduate to 2 proportion intervals. And 2 proportions means instead of just wanting to know if this new group of people are different than the old group, we want to know if 2 groups are different from each other. So we kind of change the direction we're looking. So instead of wanting to know if the proportion of high school graduates has increased from 20 years ago, we want to know if males are more likely to graduate than females, or vice versa. So we have a new issue where we have 2 samples. So if you scoot on down the page, there's a whole box of 2 sample rules. And we're going to skip past means because we're not doing means. We're not doing quantitative data. And in the second box, you have the difference of sample proportions. How different are men and women? That's what we want to know. That's like the all-time famous question. How different are men and women? Well, men are from Mars, women are from Venus, or something like that. That was a book back in the 80s, I think. So you have 2 formulas, which is 1 too many. So the first thing we're going to do is we're going to take our pencil. I had a pencil, but I loaned it out, so we'll have to pretend I have a pencil. And we're going to mark out the special case when P1 equals P2. You will never need that one for the AP exam. You will never need it. You won't need it. You won't need it. Won't need it. Won't need it. Put an X through that one, the special case, so that it won't confuse you. I don't even know why they put it in there. But they do 2 sample P stuff on the, like 3 out of the past 5 years they've made you do one, and you don't need that one. You just need this one up here.
Where are Miss Rosie? I don't think we're on this one. I don't think we don't have it.
You don't have this. You don't have the special case.
Yeah, but we don't have the P1 equals P2 part. Like it's not.
Okay, so it's just okay. So, but yeah, same difference. Just cross that all out. All that equal variances part and below.
Both of the equal variances. There's 2.
Okay, hold on. Let me look at hers. Yours is really different.
Yeah.
Holy cow. Oh, my goodness. Okay, I'm going to put this under here. I'm so sorry. Now, first block never said, "Hey, Miss Rice, our book looks different than yours." They just kind of sat there in oblivion and said, "We're just going to pretend she's not talking to us." So, first block is still confused because they got the same books you all did. All right, where it says equal variances, mark out that whole section there. That bottom section that says equal variances, mark that one out. That bottom row. And then the one above it is the one you actually need. Thank you. I'm so sorry about that.
What about the second row?
We'll get to that when we get to T's. You don't need that for a couple chapters yet, so just wait.
So we don't
wait on that one.
Difference of means equal.
Don't worry about means right now. We're only in proportion world, so we only care about this one. I do not know where that copy came from, but I managed to. You know what? I printed off one. I don't even know where it came from. I've been printing the same blue book since 2009, and I have no idea how I ended up with the wrong copy. Good grief. Okay, let's move on because I think I've already beat that horse enough today. So here's the difference. When you get into the mechanics for two proportions, that's really the only difference other than one, we have to tweak our conditions checks a little bit. But the big difference is in the mechanics. So what I want you to do for today is just don't even look at the hypothesis test side. We're not going to do that until at least Wednesday. So don't look at it yet because it'll scare you, and I don't want you to be scared because it's not as bad as it looks. But I don't want you to be freaked out, so just don't even look at it, okay? On the confidence interval side, our statistic changed from a single p-hat to the difference of two p-hats. So we're going to do like p-hat of the males minus p-hat of the females or vice versa. So we're comparing two. We're always wanting to know how different they are. Because we're assuming they're different. If they're the same, we wouldn't bother, right? Yes?
I remember when we did that thing where we switched to normal distribution.
Uh-huh.
Is that this?
Yes.
Disguise?
Yep. Well, it's not disguised, but this is it, yes. So it's now, the whole thing's out of the box now. All right. Then the standard error, you're not going to worry about this notation because, frankly, you're not going to write it down. You're going to just put it straight into your formula. This is your formula that was in the blue book, but this one's a little prettier because we have Q's instead of 1 minus P's. So if you look at just half of it at a time, you'll notice that it's really just square root of P hat Q hat over N, but it has subscripts now because you got to do it for men and women. And so you do it for one group, you do it for the other group, and then you add and take a square root, which is basically the Pythagorean theorem applied. Back when we did the Detmer dogs thing, we did like the Snoop Double Dog specials, and we added a dog plus a bun and all that business, we built the idea behind this formula. So this is that Pythagorean relationship at work. You don't have to derive it. All you have to do is know how to look it up when you need it. So you can either store it in your calculator, store it in your brain, probably wouldn't hurt to put it both places, and it's in the blue book. In that third row, that I'm not going to open this because like I said, that says difference of two proportions. Okay? So this is your formula, and we're just going to replace the 1s and 2s normally with something in context like M for male and F for female because that's easier to keep up with. Okay? And then we'll plug it into the confidence interval formula, which is here. So the confidence interval formula, we're replacing the difference of two P's with AP with the difference of two P's, hats. Plus or minus D star behaves the same as it always did. It's still the area under the curve cutoff. So it's still that inverse normal thing. It's 1.96 for 95%. That doesn't change. But the formula for standard error is bigger because you've got to actually crunch two of them together. All we have to do is learn how to stick the numbers in the right place. And we really already know how to put numbers in the right place. We just have to put more of them in at a time. Okay? So that's the formula. Now let's go ahead and apply it. We'll go straight to an example. In October 2000, the U.S. Department of Commerce reported the results of a large-scale study on high school graduation. Researchers contacted more than 25,000 Americans aged 24 years to see if they had finished high school. 84.9% of the males, big group, and 88.1% of the 12,000 plus females indicated they had high school diplomas. So in this sample, there was a higher rate of females than males. Now, it could just be this one sample is interesting and that happened. It could be a different sample. The males would be higher. It could be in another sample. They could be equal. There's lots and lots and lots of samples possible. We have one. The 84.9% is the sample P hat for males. 12,460 is the N for males. And then we've got 88.1% and 12,000 or so P hat and N for females, which means we're going to have to throw some subscripts in to keep those straight. Okay? So we're going to check assumptions, conditions for inference, and then ultimately we're going to do a confidence interval to compare the difference. Okay? So I had to cover them up on the board, but surely we know them by now. What's the first thing we check for? Randomness. And unfortunately, they didn't tell me it was random samples. On the AP exam, they pretty much always tell you it's random samples, so that's a good thing. They're kind of nice to us that way. Here, we just had to assume they're representative samples, but that's all we got. But now, the catch is you got to write a little bit longer sentence because you got to check both groups, but you're going to do 2 in 1 sentence, so you don't have to write like 8 different sentences. Okay? So we're going to assume that the sampled males and females were both representative of their populations. Alright, I got an extra R there. Okay. It's a longer sentence because you got to do both groups. They both have to be representative or random samples. Random would be easier. We can just say both males and females were randomly sampled or random samples. It would be shorter. So that's what we hope for on AP exam day. All right, that one, I don't have any reason to not believe it, so I'm just going to roll with it. Now, what's the next thing we check for? 10% condition. So is 12,000 or so males less than 10% of all the 24 males past, present, future? Yeah. Sure. Same thing for females, right? But we have to say it for both of them, so it's a little bit longer sentence, but we can make that work. So 12,460 and 12,678 are both, I got too many 8s there. I can't write today. Are both less than 10% of all 24-year-old males and females. And I made a mess of it. Okay. Takes a little more work to write it all down, but it's the same idea. You've already pretty much mastered this. So you just say it for 2. Now, here's a new piece. And then we'll do our NPs and Qs, because I always like to end with that one. Okay, so one thing that's important that we didn't have to do before for 2 samples is that the rule for calculating that standard error, that big ugly square root formula, that rule only works if we have independent samples, like the males are independent from the females. Kind of like dogs and buns had to be independent of each other back when we did that activity. And so we have to check for that. So there's an extra one always when you do 2 samples. It's unfortunate, but it is the truth, because the formulas don't work right otherwise. Is there any reason for us to believe that the males that they sampled and the females that they sampled have some connection to each other? Like one's graduation rates affects the other one? I really don't have any reason to believe that. So I'm going to assume that male graduation rates are independent of females. Okay, it's short and sweet, but it's got to be checked. All right, if we don't have a reason to disbelieve it, we'll assume it and it'll be okay. Now we're back to what we know. The NPs and the NQs have to all be at least 10. There are 4 of those to check because you got to do it for both groups. So this one's long and the numbers are big. So this is what Ms. Rice is going to do. I already have the numbers crunched, so I'm just going to feed them to you. Okay? So let's start with the males. N of males times P hat of males, and you have to specify, so use a subscript. You can use 1s and 2s if you want to, but those are just way harder to hang on to than M's and F's. Be smart about your stuff, okay? So number of males was 12,460 times p hat, because we don't have a true p here, we got to go back to p hats, and that was 0.849. And these are bigger numbers than they would ever give you on AP exam day, just because you don't have time to crunch them. But, you know, in the class, Miss Rice has already crunched this, so she's going to tell you that that's about 10,579 if you round to the nearest whole number. And I'm going to go ahead and round it just because it's so big already, and when I use the calculator later, I will need a whole number of successes anyway. It's definitely bigger than 10, that's all I care about. Alright, then N of the males times Q hat of the males, so the failures are 12,460 times, well, let's see, if you subtract 84.9% from 100%, you get 0.151. And if you multiply that, you end up with 1881. Definitely bigger than 10. You have to show the numbers, and you're going to need those numbers to punch them in the calculator later. So you might as well just, you know, put your big boy britches on, big girl britches on, and just do it. It's got to be done. All right, let's do females. So I'm going to go over here to the side. NF times P hat F is 12,678 females times 0.881, which is approximately 11,169 females who are graduating out of that group. And then N of F times Q hat of females is 12,678 times the other 11.9 or 0.119%. And that is about 1,509 females if you round to the nearest whole number, which we'll do fine. Okay, and then those are all bigger than 10, so I'm just going to make a blanket statement. All successes, failures are at least 10. Check. Okay. All right. Is it obvious that the longest part of the process is the conditions? Okay. Nobody likes to write conditions. We're just going to say it. Nobody likes to do it, but it's points and we got to. Once we check conditions, we don't have any reason to disbelieve these. What's the next thing we should do?
Tell them what we're going to do.
Tell them what we're going to do. So we will use, actually I have to look at the next page where it says create a 95% confidence interval. I need to do a confidence interval, but I haven't looked a page ahead to see that yet. So use a, what do you think we should call this one? A 2 proportion Z interval. Okay. It's the same name as the old one, but we got 2 proportions instead of 1. There we go. The worst is over with. That was long and ugly. Okay. So make sure you got that caught up. I'm going to flip the page as soon as you're caught up.
This is nasty.
It's nasty. Okay, so nobody hopes for a 2 proportion P procedure on the AP exam, but it's been on 3 of the last 5. So I'm preparing you because that seems to be a popular choice these days amongst the people who write the exam, and we've just got to be prepared. Because we nail it, it just isn't what we hope for. Because it's the longest one that they could ask us to do. All right, here we go. Create a 95% confidence interval. So now we're up down to mechanics. And so, you know, I can always peek back at my formula over here. So if I kind of lay them side by side, there's my confidence interval formula. So I just need to stick some numbers in. So I can do it males minus females or females minus males. So it doesn't matter which way, but I'm a creature of habit, and this is what I like to do. I like to put the bigger one first minus the smaller one because then I get positive numbers, and those are easier to interpret, but it'll work either way. The females had the higher proportion in the sample, so I'm going to do females first just because it'll be easier for me to summarize later. But again, you can do it either way. So I'm going to start with P hat of the females. P hat of the females was 0.881, right? Minus P hat of the males, that was 0.849. And I'm going to put that in parentheses for my sake because that's my statistic. The difference of the 2 proportions is my statistic. Then I need a plus or minus. What's the Z star for 95%? 1.96. That's old news. And then I'm going to multiply by this really hairy little standard error formula right here. So square root of, and I'm doing females first, then males. I'm going to keep that order. So p hat for females is 0.881 times q hat, which is 0.119, over the sample size of 12,678. Numbers are huge on this one. We don't hope for those. That's why we're doing this one together, because then I'll leave the not so nasty ones for you to do on your own. Plus, do the same thing for males. So, p hat for males is 0.849 times q hat, which is 0.151, over the sample size of 12,460. Okay, that's not nearly as bad as checking the conditions. It's a lot of stuff, but it's not hard. It's just making sure you're getting your right parts in the right place. Okay? Then the calculator is going to finish it, because the calculator does beautiful things. Thought I had my calculator laying here, and I didn't. Let me get it out. Okay, so let's check it out. If we go to menu, statistics, confidence intervals, we've seen this before. What might be helpful in that list? Two proportions. Now be careful of this two samples the interval. That's different. Two proportions the interval. You want number 6. So go with number 6. Notice it asks us for successes. That's an X1, not a p hat 1. So that's the actual number of females, which is back on this other page. Let me pull that back up. Those numbers are all right here. So the successes for women right here was 11,169. So that's why we need to make sure we work that out in our conditions, because we're going to need that number, 11169. If you don't round it in your work, make sure you round it when you put it in the calculator, or it will not do it. And then the sample size is 12678. And I'm doing X1 as females because that's the order I put them in the formula, and this should match. Then we do males, and the male successes were this 10,579. So 10579 out of 12460. So it's a lot of number crunching, but the calculator will do the worst of it. So that's good. At least at the end it will. And everybody okay with that? Leave your confidence interval 95%. And then you get a whole mess of stuff there. The lower and upper bound are the only ones we really care about. It does tell us that the p-hat difference, so the actual difference in the samples was about 3.2%. The females are about 3.2% higher graduation rate than the males. That's just in this one sample p-hat though. We can kind of check numbers here. That p-hat 1 is about 88.1. p-hat 2 is 84.9. Those have a little bit of decimal round-off error just because we rounded our successes, but it's close enough, so we'll not worry about that. All right, so the lower bound is 0.023-ish, comma, upper bound of 0.040-ish. So now the worst is done. We are ready to write a conclusion. If you can get through the conditions, everything else is way nicer. So we are 95% confident that between 2.3% I don't like the way I'm wording this. And I'm using a pen, that means I have to mark it out, and you have to do that too if you use it. That females have a graduation rate between 2.3% and 4.0% higher than males. Okay, so you have to kind of change your wording a little bit to make it a comparison of two groups. And that's ultimately what it has to be. There's more than one way to write that, but there has to be a comparison word. More than, less than, somewhere in there. How we doing?
Bad.
Questions, comments, teardrops? It's ugly, but you guys can do this. Okay? It's definitely doable. It's just ugly. All right, there's one last little question at the next slide that says, does this provide strong evidence that girls are more likely than boys to complete high school? Well, it's all positive, right? 2.3% to 4% higher. So if it were negative, it would have meant boys had a higher rate. If 0 were in there, it would have been inconclusive. But since the whole thing is positive, then that actually is some evidence that it's a little bit higher. Not a whole lot, but a little bit. So let's say yes, since the entire interval lies above 0. Because 0 means they're the same. If it's above 0, females are higher than males. Based on this sample, it could still be wrong. It's just based on one sample. We could take another sample and males could be 5.6% higher. Then we'd really be confused. So there could be, could be an interesting sample going on. All right, that's enough. Day 1 homework. It's not printed there. I'll have to give it to you. And I gave first block the wrong stinking page number, and I don't know why, so I'm going to have to look up the right page number, because I gave them page 508. 508 is like chapter 19, so that's wrong. It should have been page 557. And we're going to do 3 through 9 odd. Just 4 questions, so don't panic. And they're not all 15,000 steps long. They're just not. Some of them are short, big idea things. I don't have my work is out and not scanned yet, so I'll get that in the computer later and upload to Schoology and hang it over here on the board for you to use. It took longer than I was hoping it would, but hey, we got it done. So that's all good. And we got it recorded for posterity so that